Let's run through an example of evaluating whether a function is even or odd. So this is my function, and I always should start by making a graph, because that'll give me some kind of an indication. So I'm going to put it in my calculator, and this is a rational function. It has a numerator and a denominator. I need to make clear when I'm entering in my calculator which is the numerator and which is the denominator, and I like to use parentheses for that. So I go negative x, caret 3, and I close my parentheses, and I'm dividing that by parentheses 3x squared minus 9, close parentheses, zoom 6, and I'm going to get a graph here. Well, that's an interesting function. And to me, it looks like it could be odd, because everything that's in quadrant 1 seems to be reflected in quadrant 3, and everything that's in quadrant 2 seems to be reflected in quadrant 4. So that would make it symmetrical over the origin. So I kind of think it might be odd, but now I'm going to test it algebraically. And I always start testing by first testing for even and then testing for odd. So there's f of x. So f of negative x, I'm going to take negative x and evaluate my function for negative x. So I have negative x cubed divided by 3 times negative x squared minus 9. I'm going to simplify that a little bit. That gives me, well, negative x cubed is still negative x, so that's going to be negative x cubed divided by negative x squared is positive x squared, so that's going to be 3x squared minus 9. So that is equal to x cubed divided by 3x squared minus 9. So now I take a look. Is f of x equal to f of negative x? Is this equal to that? No, this function is not even. But now one thing that I've done, which is kind of nice, is that by starting by finding if it's even, I've already determined what f of negative x is. This over here is f of negative x. So now I'm going to see, well, what is negative f of x? So I do it just like this. I take f of x, which is negative x cubed divided by 3x squared minus 9, 3x squared minus 9. And all I do is I put that in parentheses, that was f of x, and I stick a negative sign in front of it. Now, it gets a little bit confusing with functions, but I'm going to take a little detour here and remind you. Negative 2 over 3 is equal to either negative 2 over 3 or it's equal to 2 over negative 3, but it is not equal to negative 2 over negative 3. So when we're dealing with this right here, we have to make sure we either put the negative sign towards the top or the negative sign towards the bottom, but not both. Okay? So remember, I'm trying to see, is f of negative x, is f of negative x equal to negative f of x? And I'm going to try and simplify this piece of it. And looking at f of negative x, I see I have this denominator, 3x squared minus 9. Well, I have the same denominator down here in negative f of x. So I probably don't want to put my negative sign towards the denominator. I'm going to put my negative sign, I'm going to distribute it to the numerator, and I get x cubed, because negative x cubed, over 3x squared minus 9. And sure enough, these two things are equal. F of negative x is equal to negative f of x. So this function is odd. And that's the way that I show it algebraically.